Hello everyone, welcome to this video on the prerequisite of a Laplace transform. So in this video, I will show you total 18 formulas that you learnt in your 11th and 12th standard. If you are able to recall or if you are able to remember these 18 formulas, I will tell you that you will solve almost all the examples of a Laplace transform. So, which are that 18 formulae that you should remember? So, mainly you have to remember the 7 formulas from a trigonometric, 7 of integration, 3 from a differentiation, and 1 of a limit formula. So, actually, this limit formula you require for only one example. So, mainly these are the 17 formulas that are mainly the important to solve almost all examples of a Laplace. Okay. So, the first set of the formula is from a trigonometry. So there are total 7 formulas and they are on the screen. Mainly these formulas we require whenever there is a multiplication of a trigonometry function and we have to find the Laplace. Actually, we convert this multiplication to the addition and then we can easily use that linearity property of a Laplace and we can get the Laplace there. Okay, so I suggest you should take a pause this video, take a pen and paper, and you should able to write these 7 formulas. You should able to recall, but by chance if you're not able to recall, yes, you can continue the video and you can see the formulas first and then try to remember it. Okay, so but once you complete entire video, after that also you should able to write these formulas without looking. That means you should able to remember these formulas. Okay, so take a pause and write down. Okay, so here are the answers. The first formula where we want cos square theta. So actually it is from the double angle formula for cos 2 theta and it is given as 1 plus cos 2 theta 1 plus cos 2 theta upon 2. Next is a sine square theta. We have 1 minus cos 2 theta upon 2. Third formula, sine cube theta. This formula actually you can derive it with the sine 3 theta formula. Sine 3 theta is a 3 sine theta minus 4 sine cube theta, and that can be rearranged, okay, for sine cube theta, because you can see this formula sine 3 theta is 3 sine theta minus 4 sine cube theta. Now you can able to write the formula for sine cube theta as 1 by 4 times 3 sine theta minus sine 3 theta. This is the formula for sine cube theta. Similarly, we have the formula for cos 3 theta, and that formula is a 4 cos cube theta minus 3 cos theta. Okay, and because of that we have the formula for cos cube theta as 1 by 4 times cos 3 yes, this is a cos cube theta is 1 by 4 times cos 3 theta cos 3 theta plus 3 cos theta, is it? So that about the formula for cos cube theta. Last three are from the defactorization formulae, where multiplication of trigonometry we are writing in the additions there. So sine a cos b can be given by 1 by 2 times sine of a plus b plus sine of a minus b. Next, cos a cos b is given by 1 by 2 times cos of a plus b plus cos of a minus b. And the last, sin a sin b is given by 1 by 2 times cos of a minus b minus cos of a plus b. So this way you should remember the 7 formulas of a trigonometry, and yes, that we require in converting multiplication into the addition. Okay, so that about the first set. Let me move to the second set of the formula. Second set of a formula is from integration now. Now again there are these 7 formulas that we have, and these formulas mainly we require for proving the standard results when we derive. Actually the derivation of the standard results is based on these integration formulae, because the definition of Laplace is in integration only. Then in the properties like division by t property or periodic function property, we require these integration formulae. Not only that, when we have to find out the Laplace transform by definition, again we can use these formulas there. So roughly in 3-4 types there, we require these integration formulae, and only these 7 formulas are enough. Remember, in 11th and 12th, you may learn 20 formulas of identities, 20 formulas for derivative, 20 of integration. Not all these formulas you require. Just to remember these limited 18 formulas, and you can solve all the problems here of the Laplace. So take a pause again, take a pause and complete it. Okay, so I hope you completed these. If you completed, that's a good. Otherwise, just go through these answers here. The first one is integration of e raised to ax, and it is a e raised to ax upon a plus c. C is the constant of integration. So that is integration of exponential function. Next is integration of x raised to n is x raised to n plus 1 upon n plus 1 plus c. And obviously there is unwritten condition, n is not minus 1, because when n is a minus 1, that become integration of 1 by x, and the answer is a log x there. Third is 1 upon x square plus a square, integration of 1 upon x square plus a square. It is a 1 by a tan inverse of x upon a plus c. Okay, the next two are, that is fourth and fifth formula. These are actually the results of integration by parts, but instead of doing it by parts, I suggest you should remember these shortcut formulas, because these formulas are useful in Laplace as well as in the Fourier series also. So the formula is like this: integration is e raised to ax upon a square plus b square, a sin bx minus b cos bx, a sin bx minus b cos bx. So that about our first formula, plus c, obviously that constant of integration. Similar formula for integration of e raised to x into cos bx is e raised to ax upon a square plus b square, a square plus b square, a cos bx plus b sin bx plus c. C is the constant of integration. Okay, so that about the fourth and fifth. Sixth formula is actually the particular case of, this is actually a substitution method only. When we put fx is equal to t, we get that f dash x dx is equal to dt. So integral of dt by t is a log t. Hence this integral of f dash x upon fx is log of fx, plus c. So it is like integration is log t. And the last one is integration by parts. It is whenever we come across multiplication, we can apply this by parts. And for by parts, we select the first function by eyelet rule. Okay, and the by part goes like this: first function, that is u, into integration of second minus integration of derivative of first into integration of second. So that about the integration by parts there. So these are the 7 formulas of integration you should remember now. Okay, so we'll move to the next then. Third part. Third part is a derivative formula actually. The there are only three formulas we require from the differentiation, and all these three formulas we require in only one property. When we use that, when we are going to find out Laplace transform by multiplication by t property. Okay, Laplace transform by multiplication by t property. That time we require these three differentiation formulas. So you should able to recall these formulas. So take a pause, write down on the paper, and then move ahead. Okay, done. So the first formula, derivative of x raised to n, is n into x raised to n minus 1. N into x raised to n minus 1. That is a derivative of x raised to n. Next is the derivative of 1 by x. So don't say log x. This is a common mistake that many of students giving at the time of interview also. They ask instead of giving the derivative of 1 by x, they gives the integration of 1 by x as a log x. So derivative of 1 by x we get by the same formula, just we have to replace n by minus 1, and derivative of 1 by x become minus 1 upon x square, because here it become minus 1 into x raised to minus 1 minus 1, that is minus 1 into x raised to minus 2, and that become minus 1 upon x square. And the last one is a quotient rule of derivative, and the formula goes like this: denominator, which is v, into derivative of a numerator minus numerator into derivative of a denominator upon denominator square, and that about the quotient formula of a differentiation. So these are the three formulas which are important for the Laplace transform examples. Okay, and the last one, which already I told, this formula of a limit we require only in only one example, where we are going to find the Laplace of the derivative again, like Laplace of the derivative of sine t by t, something like this, sine t by t. So in such for that time only we require this property, this value. But yes, that's only one example where we require this value. Actually we are finding limiting value of sine t upon t, and if we replace t by 0 directly, we get that 0 upon 0 form, because sine 0 is a 0, t is a 0, so it's a 0 by 0 form, it's an indeterminate form. And to get the value of indeterminate form, we apply L'Hospital rule, and we say it's a limit t tends to 0, that f dash t upon g dash t. So differentiate the numerator separately, derivative of sine t become a cos t, and derivative of the denominator t becomes a 1. And now if we replace t by 0, cos 0 is 1, and the denominator is 1 already, so it is 1. So by L'Hospital rule, limit of sine t upon t as t tends to 0 is 1, or directly there is a property that you learned in 12th, limit of sine t upon t as t tending to 0 is 1. Okay, so that about this value we require in one of the example. So that about all 18 formulas. So mainly we completed 7 formulas from the identity, trigonometric identity, 7 from the integration, 3 from the differentiation, and that 17 formulas are mainly the important. And if you are able to recall now all these 17 or 18 formulas, I will tell you that you can do any numerical of a Laplace transform. Okay, because that about a prerequisite formulas for a Laplace there. Okay, so thank you so much.